Hello and welcome to C# 102, Week 6. I'm going to be here today, and so will Gavin.
Hello.
Hi. Okay, so we're going to be talking about a few just different odds and ends. So today is probably going to be a fairly quick class. So I really encourage people to ask questions and really get to understand the concepts that we're going to be going with today, because there's not a whole lot and they're fairly straightforward. So let's go ahead and fire up a new project and see what we can knock out.
So what are you planning on diving into first this week, Mr. Nelson?
Well, I'm going to go ahead and we're going to talk a little bit about the using construct and IDisposable. And just we're going to have a nice little review over exception handling too, because the using construct really does play into some concepts of exception handling. So let's go ahead and talk about saving data to a file real fast, because at this point everybody should be more or less familiar with what I'm about to show. Okay, so how's everybody feeling about this code? Any questions about this code? We should already have a really good understanding of this. We should already know that the stream writer, given a string, and especially a string like this, which does not define an absolute path but a relative path, is going to result in opening up a file handle to the out.txt file. We'll create it if it doesn't exist already. And then we can write to the file via the write line or write methods made available to us by this object. In addition, we've also covered the using statement a little bit already. We've talked about the using statement, how the using statement will cause the stream writer to be immediately destroyed and closed and flushed at the end of the block on line 19. So if everybody's good with this, just basic stream writer using stuff, then we can move on, because what I'm about to show you guys is what the using statement gets compiled into, because the using statement is actually a little bit of syntactic sugar that is used specifically for deterministically destroying unmanaged resources. And when I say deterministically destroy, I mean in C# we don't have this concept of destruction in C#. Because when we allocate memory and we create objects, those objects will be resident in memory until they're no longer used, and then that memory will be reclaimed by the garbage collector at some point in the future. However, that removes some control that we have. As far as memory concerns, it doesn't really matter. Memory is managed for us, but memory is not the only kind of resource we can allocate to our program. We have a variety of unmanaged resources that we can allocate, particularly file handles, because we need to ask the operating system for permission to modify a file or to read from a file. And to do that, we need to request a file handle from the operating system itself. However, there's no real built-in way to support the concept of handling or handing back that file handle when we're done, because, like I said, memory is managed automatically for us. So we need a way to deterministically, to knowingly, to explicitly release or give back unmanaged resources that are not going to be handled by the garbage collector. I really want to point out very quickly here that C# does have this concept of a destructor. They're actually not called destructors in C#, which I'm glad that they're not, because they don't really follow the same. They're similar but not the same. In C# you have what are called finalizers. And a finalizer is a special thing you can put on an object. So for example, I can have a person, and I can go ahead and give him a finalizer. And what a finalizer is I just want to point this out for people who may see this code written. And you'll notice people in the C++ course might look at this and say, oh, this looks like a destructor. Well, it's not a destructor. It's similar to a destructor, but it's not. It's called a finalizer. And what a finalizer is, what a finalizer is is basically when the garbage collector actually goes about, and you notice it did terminate my program. It waited for a second and then it terminated it anyway. When the garbage collector actually goes out and releases the memory associated with my person, it'll invoke the finalizer for us, which might seem like a great way to release unmanaged resources. However, we really have no control over finalizers. Well, we kind of do. I could say, for example, p equals null gc dot collect gc dot wait for pending finalizers. We could do this. This code will result in the finalizer being invoked. As you'll notice when I run this, it says finalizing person.
What is GC?
This is how you access the garbage collector and get into the garbage collector and tell it to do stuff. However, you really shouldn't mess with the garbage collector directly very often unless you know exactly what you're doing. So as a result, finalizers aren't really the preferred place to release unmanaged resources. In fact, the most appropriate thing I can think of for a finalizer is to detect if your object has already been deterministically destroyed. And if it hasn't, to inform the developer that they've made a fatal mistake. Because finalizers may not execute on the same thread of execution of your main program. You don't have direct control over when they execute, nor do you even have direct control of whether or not they will ever execute. So they're not the appropriate place for releasing unmanaged resources. And in fact, their use is very, very limited in the C# programming language, and I've never found an appropriate place to use them. So I just wanted to point out that C# does have a sort of pseudo-destructor thing that a C++ developer might say, well, why don't you just use destructors? And then they go and they look and they go, oh, finalizers are like destructors, I'll use this. And they're not the same thing. They shouldn't be used the same way. When releasing unmanaged resources, you should use the IDisposable interface. And the IDisposable interface plays to the using construct. In fact, if I were to write this code in the exact way that the C# compiler transforms this code, it would look like this. I'm going to forego implicit typing for the moment. This is the code that a using statement actually results in, literally. Now, there are a few other variants on this theme, depending on if you're working with a dynamic type or with a value type. But for a reference type, this is what the code is going to look like. You'll notice that the initialization right here looks the same. We initialize our variable, and we initialize what's called the resource to a variable. And then we open up a try block and we actually put the result of the using statement in. And then we open up a finally block where we explicitly cast the object to an IDisposable and invoke the dispose method. Can anybody think of a reason why the code would expand to this as opposed to this? Why is this appropriate and valid code, or more valid than what you would typically think that the using statement would expand to when it would just invoke the dispose method directly? Can anybody think of a reason? So we got a few answers. The biggest reason is that, remember, you can implement interfaces explicitly. In fact, in earlier versions of the .NET framework, the dispose method wasn't even implemented explicitly and didn't even exist on the stream writers. So we cast it to the IDisposable because of the nature of interfaces, to ensure that we're invoking the appropriate IDisposable method as opposed to in the case of an explicit interface implementation. So that's the reason why. Can anybody think of why
Yeah.
this outer block is necessary? That block started on line 21, ended on line 35. Yep, the whole point of this extraneous block is to ensure that the SW variable is not accessible outside of the scope. It's all about scoping. So you'll
You
notice...
did that in a video the other day. I've got to bring up extraneous, not extraneous.
Okay, we did have a few questions. What are unmanaged resources, though? Unmanaged resources are resources that aren't managed.
Well, I mean, I can show you, I've had an idea of a good way you can show that, actually. If you copy line 37 and put it on line 19, or you could just put a breakpoint, but that would be, either way works. Will that file, I'm wondering if this will do, will that be there?
It should be there, but it should be empty.
Yeah, but it'll be there.
It should
see where
be
I'm
there.
going with this.
Yeah. Actually, let me go ahead. I have to save this out to a physical location on my hard drive. Run it again. Open up my Explorer.
So at the moment, we've paused the program, essentially, on line 19.
Yep. So we paused the program immediately before the ending of the block. And the ending of this block corresponds to the finally block that you see here in line 34. You'll notice the file is empty. If I hit a key and reopen the file, it will now have text. It'll now have text in it. And the reason is the unmanaged resource of the file handle was requested by our program, but not given back to the operating system. In addition, the buffer that was used internally by the stream writer to prevent creating a bunch of disk-write operations during the execution of your program wasn't cleared yet. Disposing of the resource not only cleared the internal buffer, but also handed the file handle back to the operating system. Because you'll notice that if I run this again, before I close that handle, I can't delete out.txt.
There we go. Yeah, that's what I was aiming for.
This action cannot be completed because the file is open. An unmanaged resource is a resource that you ask the operating system for that isn't memory. Remember, memory is managed in C#. Memory is managed for you. You don't have to delete any memory. But that's not the only kind of resource you can ask from the operating system. So what I mean by managed is managed.
C# is managed code. Unless you specifically say, right, don't manage this.
Which you can, sadly, with unsafe. But
yeah, that's...
I hate unsafe. Anyway, yeah, the C# is a managed language, meaning that there's this little guy called the CLR who kind of loads himself into every process and sits there and manages things. He cleans up after you. He makes sure that there's enough memory for you. Performs quite a few interesting operations for your program that makes writing code very, very, very straightforward and nice. Which is one of the major benefits of using C# because it is a managed language. So an unmanaged resource is anything that the CLR doesn't know how to dispose of properly, which is typically going to be file handles. What about ensuring something isn't garbage collected? You should never do this. Never. In fact, if I vaguely remember, yeah, you can actually prevent an object from being garbage collected ever. You can also prevent an object from having its finalizer invoked. But here's the thing. You really shouldn't ever do that. Garbage collector will only collect your memory when it's no longer being referenced by anything. When no local variable or no field points to memory. So until something is null, until an object reference is null, that memory allocated for the object reference will never be collected. So it's never going to destroy something. Unless you're using a weak reference, which you can use a weak reference, but that's kind of out of the scope.
Huh.
Doesn't the garbage collector slow things down a bit? The garbage collector is highly efficient and extremely highly optimized to handle the creation and destruction of transient objects. When I say transient object, I mean small object instances that are only around for a short period of time. It's insanely optimized for that particular case, but it also has contingency in the case that an object is longer lived. What happens is there's different generations of the garbage collection. Every object is in a generation of the GC. When first you instantiate an object, it's going to be in the generation 0. And when the garbage collector decides to do its thing and free up some memory, it's first going to loop through all the generation 0 objects. And any object in generation 0 that isn't referenced will be deleted, and every object that is referenced will be moved to the next generation, and so on and so on. So it really optimizes the concept of both transient objects and also long-lived objects. It's a very highly efficient thing that can cause problems. No, the garbage collector does not use reference counting.
Does that mean that essentially the longer your program is running for, providing there's a sort of a throughput of objects being created and disposed, you're going to end up left with the largest ones left in memory, generally speaking? It sounds like it's going to end up clearing out the smaller.
It's not necessarily about small or large. It's about how long-lived they are. The longer lived an object is, the fewer times the garbage collector will even check to see if it needs to be collected. Which makes sense, because a lot of times you'll instantiate an object and have it around for your entire duration of your program. You don't want the garbage collector to have to ping it every, however often to find out if it needs to be collected.
Well, similar to the way that when a list resizes, it exponentially grows in terms of how much it resizes itself, so it doesn't have to do it so often.
Yeah. There is also something called the large object heap for particularly large objects, but that's a completely different aspect of the garbage collector. It was funny. It's funny that the Stack Overflow actually had a recent problem. I think it was a few months ago, where the garbage collector, basically what happened was they had millions of these tiny objects that were long enough lived to exist in later generations of the GC, but not long enough lived to where, or not necessarily used for a very long period of time. So what happened is that the performance of Stack Overflow would actually drop. I think it was every 12 hours or something when it did a huge generation 3 cleanup or generation 2 cleanup or whatever. And that was actually a significant performance degradation that was caused just because of the garbage collector. That being said, that is the only story I've ever heard in my entire life that actually has to do with the garbage collector making a significant performance impact on a program. And remember, we're talking about Stack Overflow here, one of the largest, most widely used websites on the planet that lives on a single server. Or actually, no, I think they do load balancing now. I can't remember. They're really open about their architecture and stuff. It's really cool to read how they approach their scaling. But remember also, Stack Overflow is also one of the fastest sites on the internet and is completely written in C#. So there. Let's see. What's a weak reference? A weak reference is something that's out of scope. There's a few people pointing out why the C# compiler doesn't explicit.
Do you mean out of scope of the class?
Yeah.
As opposed to out of scope?
Yeah, out of
seeing
scope.
as we are actually talking about scope.
You can do some fun stuff with weak references. Blah, blah, blah. Okay, so people are still confused as to why the code expands to this instead of this. I do want to point out that this code would work in a variety of cases. sw.dispose will work. But it didn't used to, actually. The stream writers, if I remember correctly, in earlier versions of .NET, didn't actually have a dispose method on them. They implemented the IDisposable.dispose method explicitly. And we're going to discuss that a little bit more once we start talking about implementing our own IDisposable. Because we can do some fun stuff.
When did it get changed then?
I want to say .NET 4. And that's only if I'm remembering correctly.
Change your, do that. Do what you're doing.
Let's jump to 3.5 and see what happens. Because we should get a compilation error.
Because actually, and I'm going to bring this up on video so that at least somewhere it's mentioned and kept, which is that in one of the Antler videos, you bring in a specifically .NET 4 method reference that doesn't exist in 3.5. And that just caused me pain for about 20 minutes until I suddenly went, oh, I wonder. I can't remember which one it was.
All right, I can't remember. Maybe it wasn't the. It was something that didn't have a dispose that implemented explicitly. I could have swore it was the stream writer, but it doesn't matter.
Reader?
The stream reader, or writer, or well, they would.
No, what I'm saying is it could be. It
was something. The point is this is what it literally. I'm showing you literally what the compiler writes the code as. The compiler sees this, turns it into this. It's very important for a few reasons. First of all, it will always place everything in a try block and then follow it up with the finally, meaning this proves that the dispose method will get invoked if an exception is thrown within a using statement.
Mm-hmm.
So we'll talk about the explicit implementation later. The fact is, this particular example might have been not very good because we could have just written it as sw.dispose and work better. But remember, a method that just happens to implement an interface member may not be the actual interface member due to the nature of explicit interface implementation. Okay. So, besides line 32, how's everybody feeling about lines 21 through 34? Do people understand that this is the pattern that the C# language gives us to deterministically destroy unmanaged resources?
Cool.
Okay, so let's talk about implementing our own disposable. Does this mean you can somehow inject a catch block? No, you may not inject a catch block. That being said, there's nothing stopping you from doing this. You could do this, and this would have the same effect of doing that. But there's no way to do, there's no syntax equivalent of this. You can't do that.
Wouldn't a closer approximation be putting the try inside the using?
Yeah, that would be actually...
Put try catch
inside the using. That would probably be more appropriate. Okay, so let's talk about how to implement our own disposable. Let's take advantage. Let's abuse this using block, because I love abusing languages to do things they shouldn't do.
So, I know, I've seen some of your forum posts. Oh, Segfold said, such as speaking... Oh, sorry. Segfold said, such as speaking in it.
I don't get it.
I just found it ironic, given the way he mangles the English language, that he's berating yours. I mean, he's right, but it seems a little harsh.
Okay. So what I have now is a class called switch colors, and it takes in a foreground and a background. It caches the previous values for the console foreground color and background color, and then it sets the new values to foreground and background. Well, let's see how we can abuse the using block to do something. I'm going to go ahead and implement IDisposable. So notice how I added an implementation to IDisposable to the switch colors class. By doing so, I have now made switch colors a candidate for use within a using block. At the end of the using block, as we already know, the dispose method will be invoked, which is a great way to express what I'm about to do. I'm going to say console.foreground color equals old foreground and console.background color equals old background. So now we can kind of push and pop the different colors of our console color, of our console's color, in a nice little way. I know this is not what the language construct was designed for. I do want to point out that I still would not do this in a production application. I would use functional programming concepts to represent this. That being said, I just wanted to, I think this is a kind of an interesting example to get people's head around the concept of disposable. So
yeah, it's already makes it clear exactly what's happening when.
So now we're going to run this code. We'll see some really awful colors being represented out into the screen for us. Now I want to point out that we're not really disposing anything. We're kind of abusing the construct a little bit. The fact is that IDisposable is really appropriate mainly for unmanaged resources. However, it's not very typical that a developer would ever have to use unmanaged resources directly. Almost anything that could be represented as an unmanaged resource is probably taken care of already in the BCL for you. But I wanted to point out just the nature of how IDisposable works. And first of all, and most importantly, I wanted to introduce people to the concept of using an interface to interact with a feature of the C# language. This is actually a very common pattern in the C# language, where by having our objects implement a very special interface, the C# language will actually allow us to integrate our objects with existing language constructs in new and interesting ways.
Remember, the dispose happens at the end of the using block.
Yep.
So line 40 in this case, and at line 43 for the other one.
So just to write this out longhand, it would look something like this. Notice something also important. I did not name my objects. I did not associate these with an actual identifier, which is not a requirement to the using construct. Actually, I'm going to leave it how the C# compiler actually doesn't work, and then I'll demonstrate why it's important that the C# compiler does an explicit cast. Okay, so here's the longhand, almost the longhand without the explicit cast of what this turns into. And it might look a little bit complex to begin with, but really there's a very, very straightforward pattern that we have. First of all, we open up a block, just an arbitrary block to control scope. We open up a try block. We insert the code that they had in the using into the try block. We add a finally block that invokes the proper dispose methods. Then in this case, we repeat the pattern again. We open up a block to manage scope, open up a try block, inject the code that the user wrote inside the using block, and then add a finally that invokes the dispose method. Does using inherit from IDispose? I don't understand. Using is a language keyword. It can't inherit.
The IDispose comes from the dispose method comes from the IDispose, which is on the switch colors. That's what he implemented. IDispose on switch colors. IDisposable.
Notice if I take off this IDisposable, we'll get a compiler error right here saying switch colors type used in using statement must be implicitly convertible to system.IDisposable. But I mean, how does using know about dispose? It's in the specification. Again, this is a very interesting thing that isn't very common. Well, I suppose it is. It is relatively common in programming language, I guess you could say. But it's kind of a weird concept. It's sort of like the chicken and the egg sort of thing. It's like, well, how does the C# language know about a thing that's implemented in terms of the C# language? And the answer is it just is. C# language says in the specification that it clearly defines the existence of the IDisposable interface. And remember that the IDisposable interface isn't something that's really provided to us by C#. Well, it may have been written in C# for all we know. It may have been written in IL directly. But remember, though, that the BCL is a component that sits on top of the C# language. And the C# language specification is knowledgeable about the BCL, and in a variety of situations takes advantage of interfaces that might be made available to us. It's just in the same way how the C# specification provides us with things like for each loops, or collection initializers, or in C#4 we have the whole dynamic thing, which is another like huge integration between the BCL and the specification itself, where the C# language really does know about the BCL that's going to come with it in all cases. So in the specification itself, it specifies that any object that's being used by the using construct must implement IDisposable. How does it know about scroll up? Is dispose not coming from IDisposable for the using? Is it just looking for any method called dispose? No. No, it must implement IDisposable. It must implement IDisposable. It must implement IDisposable. Remember, if I remove the implementation of IDisposable, even though there's a dispose method, you'll notice we get errors. The using construct cannot be used with objects that do not implement IDisposable. That's an aspect of the standard of the specification. Okay, so using and IDisposable are connected. Yes, the using construct in the specification is defined as having knowledge of the type IDisposable that's provided to us by the base class library. Okay, so let's clear up the last few questions that people had. Remember how I said that it's important to note that IDisposable, there's an explicit cast happening right here. We actually get IDisposable something like this. In fact, I'm 99% sure that's how it works. But regardless, the C# language specifies that your object is converted to an IDisposable before the dispose method is invoked. And here's why that's important, and that's actually an important detail. It's kind of an esoteric detail, I know, but I just want to point it out. What if we had explicitly implemented dispose? What if we said void IDisposable.dispose? You'll notice we now get a compiler error on line 59 and 67, but we don't get a compiler error in our using constructs. So if I jump back up again, what I've done here is I still implement IDisposable, and I'm hooking this method up to the IDisposable implementation, but I'm not at the same time creating a public method on the switchColors class, meaning the dispose method is not available to any type that is at compile time typed to the switchColors class. So as a result, you'll notice that the using statements do not error out. That's because the using statements are smart enough to convert our object into an IDisposable before invoking the dispose method. Again, it's kind of a pointless esoteric detail, but I find this stuff interesting, and it's also another thing to remind people about what explicit implementation is. And you use this heavily in your room state display, don't you? Yes, I do use this quite in the current code base. The reason I do is because the constructs that I would be using otherwise are out of scope of the 1 and 2 class, and I wanted to be able to explain every line of code within the RPG game that I developed myself. I just got so ridiculously annoyed by having. I originally implemented a console colors class that had like a pop method on it, and I just got so annoyed by having to explicitly invoke the pop method because I'm so used to being able to use delegates to represent that sort of logic. So I was like, fine, I'll just abuse the using construct because I know we're going to go over it anyway.
Well, I'd say because you said this is going to be a slightly shorter class anyway, I say we take the break a little early, give anyone else a chance who has questions about using what you've covered there to put them in. And then when we get back, we can go on with the next bit.
Alrighty, so yeah, and we are now... And we're back. So, yeah, so the dispose method is not about disposing anything, but instead just about doing something at the end. And also, when is the end? When is the end? I mean, I get exactly what he's saying, but it's just it's kind of like poetic. Is it right before the GC gets rid of it? No, the whole point of disposable is that it's deterministic. The point of disposable is that you get to control when the dispose method gets invoked, as opposed to the GC, which you have no control over. Or you have a little bit of control, but you shouldn't really ever take control of the GC unless you know exactly what you're doing. Okay, so yeah, let's move on. Let's talk about nullable value types. So what is a nullable value type? And funny thing, nullable value types are actually something that, again, is a concept that combines the BCL with the C# language specification, which is really nice. Basically, a value type is anything that's a structure or an enumeration. I don't get your answer, though. Are you not disposing anything? No, in this example, I wasn't disposing anything. I was abusing the construct to save a line of code. No, you shouldn't be. However, we don't have the tools yet to represent this code in a proper way. We're going to be talking about lambdas and delegates, which is the appropriate way to inject code in the middle of initialization and deinitialization. Okay, so nullable value types. A value type, again, is anything that's a structure or an enumeration, which happens to include all of the built-in types, such as int. So if I say int my number, and I set it to null, I'll get a nice little compiler error. And that's because int is a non-nullable value type. Now, by default, all value types are non-nullable. And when they say non-nullable, it means that they can't be ever null. Never. They can never be null. It's impossible for them to be null. So what people realized was they really wanted value types to be nullable under certain circumstances. And the reason is because you often need to express the concept of, take a Boolean, for example. You often need to express the concept of yes, no, or not answered, basically. In addition, when talking to a database, if anybody's familiar with RDBMSs, such as any SQL server, so MySQL, MS SQL, Postgre, Oracle, you'll know that columns in a SQL database may be nullable, and in fact that could be desirable in some cases. So you might have a person table. The person table might have an age column, and the age column could be a number, but you might want to be able to represent the existence of whether or not that data was specified. So,
well, and indeed any situation where you've got a drop-down box, you think about the webinar, for instance, where it's got select country and select state and things like that. Invariably, they'll start off with a not selected option.
yeah, and you really want to be able to represent that in your code. So, what did the people in charge of the .NET framework do? Well, they invented something called Nullable. Nullable is an interesting structure. Now, I want to point out the funny thing about Nullable. Nullable is a structure that takes in a generic parameter. And it's not nullable itself, which is funny. But what we can do is we can say nullable int my int. And I can say, by default, my int will be null. So you'll notice that if I say my int dot, I'll have a variety of, I'll have two nice little properties. I have a has value and a value. The has value is a Boolean indicating of whether or not this value is null, and then a value is the actual value that's represented in it. So what we can do is we can say, this does get a little bit complicated, actually, because sadly, it's going to be very difficult to express what I want to, not in terms of the C# syntactic sugar built around the nullable type. The nullable type is just like IDisposable. It's a type from within the BCL, but it is also tightly interwoven into the C# specification to the point where there's a variety of nice little shorthands you can use with the nullable. For example, I can say int question mark. Int question mark is shorthand for nullable of int. MyInt and MyInt2 are the same type. There's also a variety of other shorthands. For example, I can say if myInt equals null. Now this might look a little well, hold on, let me set it to a value first. This might look a little counterintuitive at first, because you might be saying, well, wait a sec, nullable is a structure. A structure is a value type. How can a nullable of anything be null? Well, the answer is, this is syntactic sugar. Basically, whenever the C# compiler sees this, it turns it into that. So,
oh, I really want to ask you questions about IEquatable.
So my int is currently null since we're not initializing it with value. Well, actually, more appropriately, my int is actually nothing right now. In fact, it's unassigned, meaning it's neither null nor a proper value. It's unassigned. And the C# compiler is going to prevent us from using it until it's deterministically assigned. Or no, there's no.
At the moment, it does. At the moment, it still thinks it. Well, at the moment, there's still a good possibility that you just forgot to assign anything to it. So it won't let you go ahead and do that unless you say, no, I know what I'm doing. I want it to start off.
Right. The term within the specification to describe this is definite assignment. In C#, you may not access a value that is not definitely assigned. Definite assignment prevents you from using uninitialized variables. And definite assignment is a very complex, it's actually more complex than you might realize at first, but it's a complex algorithm that prevents you from making stupid mistakes. In this case, although myInt is technically null at the moment, the fact is it's not deterministic, or it's not definitely assigned, meaning the C# compiler is going to throw an error if I try to use it. But there's a few other awesome things about nullables. So, we first went over the basic, how many times am I going to use the word deterministically? As many times as I need to express the concept of deterministicness. If that's a word.
I reckon that the number of times you say deterministically is probably stochastic.
maybe. How many words am I going to invent? As many words as I need to invent to represent my expression.
Appalling spelling.
My expressionality.
Anyway.
So let's go ahead and talk about some other syntactic sugar that nullability gives us. So I can say int ble, and I can assign it to null. Again, this is syntactic sugar for setting the has value property to false. Now we can say if ble does not equal null, and now we can say console.writeLine ble. And you'll notice it's very interesting how this all works, because we're noticing a lot of syntactic sugar going on behind the scenes. First of all, we're noticing the syntactic sugar of the question mark. The question mark wraps this in a nullable type, so it is nullable event. The assignment performs not only just a copy over to the value property of the nullable value, but also sets the has value to true. When we check to see if it's not null, it's checking the has value property. And when we actually invoke a method using our value, what we get is not the nullable thing itself, but the value that it might contain. You'll notice, though, if I were to set this to null and invoke console.writeLine ble, you'll notice we get just a null. In this case, writeLine does actually have I believe it's actually casting it down to an object of a null value in this particular case. But if we try to do ble.value, we'll get a nice little runtime exception. We get nullable object must have a value, because ble is currently set to null. So you'll also notice that there is some nice little debugger things too. If I hover over this, we see ble equals null. So the debugger understands the concept of nullability and hides the fact. Now remember, all of this syntactic sugar is simply hiding the fact that all a nullable value is it's a value that's wrapped in a structure that has one additional Boolean called hasValue. And the debugger in the C# language will do its best to make sure that we don't know that. But I just wanted to point out that that is how it works.
Marvelous.
Any value type may be made nullable. I also want to point out that there's no implicit conversion between a... Let's talk about implicit conversions real fast.
Right, now what should we talk about?
No, we're talking about implicit conversions first. So there is always an implicit conversion from the non-nullable type to the nullable type. Does everybody understand this? I can implicitly convert from the non-nullable type, which is this, being represented by a system.int32, to the corresponding nullable type, which is an int nullable called whoa.
Well, that makes perfect sense.
Yep. However, there's...
Because...
Yeah.
I was going to say, because whatever value the non-nullable type has, it's always going to be a place for it in the nullable version.
Yeah.
But you can't say the same the other way around, because the nullable version could be null.
So if I say int nullable equals null, and I say whoa with nullable, you'll notice we get a cannot convert from int nullable to int. Because the nullable could be null, and because the actual not nullable type may not ever be null, there's no implicit conversion from the nullable type to the not nullable type. Even if I were to give this a value, it doesn't matter. It just doesn't matter. There's no implicit conversion.
If you think about it, it's conceptually exactly the same as why you can't put a float into an int.
Yeah, but you can put an int into a float.
Yeah, it's the precision. It's essentially you've got space for a non-nullable int inside a nullable int, because it's just a non-nullable int with an extra value potentially of null.
So how would you do this? Well, you do something like this. You'd say if nullable does not equal null, then do woe.nullable.value. Otherwise, say console write line. That would be the proper way to represent this code, because we're going to we're first going to check to see if it's not null, which will implicitly check the has value. Remember, what this is doing right here is the compiler is turning this into nullable dot has value, and then we're invoking the function given the dot value, which is going to be the non-nullable version. Otherwise, we're going to print out a message to the user and tell them they're stupid and cry.
And a slight sidebar, but for those of you who are using Resharper, this is one occasion that you'll come across that if you're not keeping an eye on it, you can end up just endlessly checking whether things are null or not, because it will often give you the value to check whether something is null before doing something with it, essentially. But oftentimes that's not what you actually want to be doing. Before it's often indicative that you want to be doing something else to your code rather than checking whether that is null. Nelson, do you know what I don't think that's very clear, but it's just one of those things that I notice that it will tell you a lot. You'll get squigglies all over your code saying, "Oh, have you?" I mean, literally, you can instantiate something, give it a value so that it's not null, and then try to use it, and it will say, "Oh, you haven't checked to see whether this is null or not."
Yeah. I actually turn off that error or that warning, and the reason is if it's acceptable that a value passed into one of my methods can be nullable, I'll make it explicit in the documentation of that method. Otherwise, I will let my method fail. And I'll make sure it fails early on, so typically that will involve doing a null check and throwing an exception. Or I will just not do that, and knowingly that it will throw a null reference exception at the end of the day anyway. Because again, that's an example of a bug, and you never want to catch or eat those exceptions. You want those exceptions to bubble up and tell you that you have a bug in your program, and to immediately fix it. All right, so what is in .value of the int nullable? Oh, what is in the .value of the int? Funny thing, nothing. Or something, probably the default value for int. But as I showed before, if you try to do nullable.value, if you try to access the value property when the nullable is set to null, we'll get a runtime exception. We'll get an invalid operation exception saying nullable object must have a value. All right, any more questions about...
I was just going to say, so the Boolean of has value acts like a gatekeeper to the value.
Yeah.
It won't even let you get at the value if you've got trainers on.
Okay, any more questions about nullability? Straightforward stuff. You can make enums nullable, by the way. I just want to point that out. Enumerations are value objects, and you can make them null. Can you implement a list of nullable ints? You may certainly. You can use nullable anythings for anything. And I do mean to say that. I could say, I want a dictionary of list of int nullable, and then a list of dictionary of int nullable and double nullable. Perfectly valid code. Does it have to be a value type? Yes, it does. Nullable must be a value type. You may not have a nullable reference type because reference types are implicitly nullable. Is nullable of T a value type? Yes, nullable of T is a value type. So the funny thing about nullable of T is that the nullable may never be null. I've actually never tried that. There's no reason why this shouldn't work. Oh. Represents an object. Did it really fail? That's curious. The type int must be a non-nullable value type. Okay, so it does look like the... now I'm curious. Huh. See, that's interesting. Although nullable is a structure and its generic type constraint ensures that whatever you pass in is a structure, it looks like the C# language actually has a little bit of a short circuit right here that prevents you, outside of the constraints of the language itself, that you may not use nullable within a nullable, which is interesting.
How does it do that?
I'm sure you could do this in straight IL though, because like I went to the definition of nullable. Looking at this code, there is no indication as far as the way that this structure is defined that would indicate that constraint. As you notice, the generic type constraint specifies that the generic parameter must be a structure, when nullable is a structure. So there's no reason why it shouldn't be possible, but it looks like the C# compiler has some built-in safeguard against this. But like I said, I'm sure I could pull this off in straight IL if I wanted to. Don't know what it would accomplish, but I bet I could do it.
Marvelous.
Do you make value types nullable often? Is it very useful? It's useful when you need it. How do I close the tab so quickly? Typically, I have Control W bound to file.close, but because this is as a vanilla install as I could get, I don't have that bound. So typically when you see me in my other windows, I'll just hit Control W to close the current window. But to make this tab go away quickly, just middle mouse click on the tab itself, and it'll close.
Oh, that's interesting.
But I'll Control W is the is what I'll bind my file.close to. It's a very common thing. Could you derive from nullable T and then do nullable to int? I don't know. It's not sealed, so I suppose you could derive from nullable. We're getting some really crazy stuff right now. Well, looks like it's another built-in C# safeguard, invalid base type. That's funny.
What an incredibly informative message.
Yeah. I don't know why you would ever want to do that, but you could. Supposedly in IL, there's a lot of fun stuff you can do in IL that you can't do in C#. You can overload methods based solely off return type instead of just the parameter list in IL.
I know too.
Anyway, could I rewrite the C# compiler to get around this error? I could pick up Mono and edit its compiler.
I know too.
Yes, you can use an enum as a generic constraint in IL. And I said that just to get on Gav's nerves. Blah, blah, blah. So yes, nullable types are useful when they're needed. They just are. They represent, they're very representative of user input, basically, is what it boils down to. So really, is that it? Huh. Okay, let's talk about extension methods. What is an extension method? Extension method deserves a little bit of explanation and discussion. An extension method is a way to add a... What?
It's all right. I won't say that. Carry on.
Okay, an extension method is a fun little thing you can do to add member functions or methods to existing classes. However, like I said, it deserves a little bit of discussion. And also, it's worthwhile to point out that extension methods can actually be added not only to classes, but they can also be added to interfaces, enumerations, and delegates, which is kind of fun. You can do some interesting stuff with extension methods. So let's talk about what extension methods look like. Well, first of all, an extension method must always be encapsulated within a static class. Anyway, static class, yes, extension method. So the name of the extension, the class that you have an extension method within is irrelevant. You may have that named whatever you want, but it must be contained within a static class. And what's a static class? I don't think we've talked about static classes, but they're really straightforward. A static class, by adding the static modifier to a class, makes it so A, the class may not be instantiated, and B, everything defined within the static class is in itself static. So let's go ahead and define an extension method. Let's add a method to integers.
Oh no, we're into, oh no. This and that. I don't know why, but this whole this and that thing that you do, I totally get why you do it, and it still breaks my head when I'm reading things.
I prefer it. Okay, so is everybody paying attention? Because I just did something amazing.
It's truly remarkable.
Well, it is. Look on line 21. There's something odd about line 21. Can anybody guess what's odd about line 21? Something a little bit bizarre about line 21. Something that shouldn't be possible. In fact, I don't know if I've seen any non-dynamic language that makes this possible.
NATO for the win!
Yep. Int doesn't contain addOne.
Remember, my number is an int.
Yep. The addOne method does not exist on the int type. But I'm invoking it like one. Basically, an extension method is a little bit of syntactic sugar for invoking static methods on objects. The C# compiler will literally translate the code on line 21 to this. Line 22 becomes line 23 during compilation. So let that sink in a little bit. The C# compiler allows us to invoke a method as if it were a member of the object we're working with, but then translates it into a static method invocation. How does it know to do this? It's because of this.
That this.
That this. Not that this.
That this isn't a this.
No, it isn't a normal this. It's more of a that.
This is what I find confusing.
The this on this line is an indication to the C# compiler that we wish to make the addOne static method a extension method. Every extension method must always start with a parameter that is annotated with the this modifier, followed by a type that we're extending, followed by the name of the variable that will represent the object that we perform the invocation on. So as a result, the addOne method becomes an extension method on the int. And every time we invoke an int addOne, what happens is the C# compiler rewrites the code for us and passes that object into the first parameter of our static method. Very cool stuff.
Is there anything other than this, out, and ref that can appear there on line 10, i.e. that can appear as a sort of secondary modifier within a method declaration?
The only modifiers in the C# language for parameters are going to be params, this, out, ref, and attributes.
Oh, right.
Which attributes aren't technically a modifier, but they do exist with it. They can be attached to parameters.
Cool. Thank you.
But what if you call the addOne on a thing that doesn't know how to work with +1? That's a good question. The addOne extension method is explicitly typed to the int type, meaning it's only provided on the int type. If I were to change this to 10.0 and turn my number into a double, notice how I get 2 compilation errors. First of all, the code itself is invalid, my extension method, because double can't be implicitly converted into an integer. And second of all, remember the addOne method is typed to an int, because that's the type of the first parameter, the parameter that's annotated with the this modifier.
Well, this actually ties into what I was going to ask, which is essentially Segfault's question.
Which is?
Which is Segfault's usual question. Can you do this with generics?
Ooh, yes. Yes.
Because that's really sweet if you can.
You can do a lot of fun stuff with extension methods, especially how they relate to generics. So as a result, you'll notice in line 15, I actually did add an extension method to every single type on the planet.
With a void return type.
Yeah, but we're not talking about generics, so ignore that. So addOne is explicitly typed to the int type and any derivatives of the int type, which, as you know, int is a sealed type, so there may not be any derivatives, but extension methods do apply to derivative types. Is it here the same thing as in the class for the fields and stuff? Is it here the same thing as the class?
No. Read what you wrote.
Is this here the same thing as as this? Wow. You read it. I can't read that many thises.
Is this here the same thing as this in a class for its fields and stuff?
Oh.
This is what I was trying to get at before. This isn't a normal this.
No. This is, well, it kind of is. It's a similar concept. It's a very similar concept.
It's kind of like type of this to me, but that'll probably confuse things even more.
But you may only access the public members. You can't access the private members of whatever you thist.
Explain. Sorry, you seem to jump from like a scratched record then. What is that? Explain about the 2 different types of the word this.
Well, this in a typical scenario looks like this. Everybody should be familiar with this on line 14. The this on line 20 is not the same this. It's simply a modifier. However, it does kind of sort of work the same way, kind of sort of. By attaching the this modifier to this parameter, which I named that, is going to be the instance of the object you invoked the extension method on. Notice how I invoke the extension method without providing a parameter. That's because the first parameter is always eaten. It's eaten because it's provided by when the C# compiler expands your code during compilation. However, that...
You named it. I did tell you.
The parameter named that is annotated with the this modifier may only access the public members of that type. They may not access the private members of that type. I missed a week. It seems like the class turned to gibberish. When, why would you choose to use an extension method? That's actually that
is a
yeah, that's a
when you it's a chicken and egg thing again, isn't it, really?
well, I do really want to point out, however, that extension methods are abused by certain developers. They are ridiculously abused by certain developers. In fact, I'm talking about you. I'm talking about some libraries that I've seen where it's like the library author decided to segregate a bunch of functionality into extension methods when they could have just added those methods to the class that they were extending. It was like, why? Why'd you do that? All the resulting work that I have to do now is to import a using statement. I mean, come on, that's just annoying. But I find myself using extension methods for a variety of reasons. First of all, extension methods can make some really beautiful syntax. For example, assertion libraries, such as the Fluent Assertion Library, which is used in unit testing to determine if an object is of a particular state, looks like this. In this case, the should method is an extension method provided by an external library, and it's going to be an error because I haven't imported it yet, but it allows me to write some really beautiful looking code. That being said, this isn't necessarily production code that you should necessarily use. It should only really be used for testing purposes. But again, nice little thing that allows us to do some neat stuff. I also add extension methods to things for some levels of utility code. For example, I often add an extension method to my projects for hashing. If you know what hashing is, that's fine. It's an algorithm that you can process data with. So I'll do that sometimes. That's one of the most common things I'll do with extension methods. There's a few other things I'll do extension methods with, but they get sort of out of scope. However, the number one bit of awesomeness, the number one most fundamentally game-changing thing that was introduced in C# 3 by way of extension methods is the concept of adding a real-life method to an interface. So for example, this is a very bad example. I would never do this, but the problem is it demonstrates what I mean. I would never do this, though.
Well, because it enables you to avoid using an abstract class.
Notice how the print name method is now available to me on every type that implements the IBLA interface and every object that's statically typed to the IBLA interface. And I'm able to actually invoke a real-life method against an interface. That being said, I wouldn't do this. I would not do this. The print name method should really be a member of the interface. If you wanted to abstract the concept of printing the name, then use an abstract class and derive from that when implementing IBLE. However, like I mentioned before, that interfaces gave way to the game-changing paradigm shift caused during .NET 3, or C# 3, sorry, .NET 3.5, that allowed for one of the most powerful, different, and enlightening, and I'm going to make up another word, renaissanceal. That's a stupid word. But anyway, the fact is, the invention of LINQ really did cause a renaissance within the C# community, and brought functional programming to the forefront of us lowly cubicle-dwelling enterprise application developers, and it was all provided to us by way of extension methods.
Woot.
Can extension method have more than one parameter? Yes, extension method may have as many parameters as you wish. So you could do something like extend double to return the decimal value. A double is implicitly convertible to a decimal, but you certainly could. Is there a way to filter the extension method to certain types, like interface? I don't understand the question.
Same as if you're doing generics, you can limit...
Yeah, you could use generic type constraints, but we're not going to be talking about generic type constraints.
No, but he's asking, can you constrain your types with the extension method? I mean, you've shown adding one to everything, well, briefly with a generic. Is generics the only way you could apply it to a group of things?
Yes. You would use generics combined with generic type constraints. So, and this refers to an instance of type int. So if it was like a class, it would show all the methods of the int class. Yes, it would show all the methods of whatever type we passed in, but most importantly, only the public members. You cannot, extension methods do not have any magical properties. Extension methods are literally converted into a static method invocation. So for example, impl1.printName literally gets converted into bleextensions.printName impl1. Now I want to ask some people something, and I'll even invite Segfault to answer this, or try to answer this, but this is something that ties into a sort of, not a rant, but a sort of sidebar that I sort of got really involved with last week.
Before you do that, could you just check Barry's follow-up about the multi-parameters?
Doesn't this invite... so this...
Yeah.
Multi-parameters. Only the first parameter can be annotated with the this modifier. So additional parameters would look like this. Now notice that all of these become compiler errors because I have to provide a value to that parameter. So the first parameter gets eaten, the first parameter with the this modifier, and then the other parameters get used just like normal.
What does the tooltip look like for the...
looks like this.
Yeah, that.
It says extension void ibled.printName int. Okay. So anyway, backing up into a question, again, this is just to see if people actually pay attention to my random sidebars. Given that line 34 it is indeed what the C# compiler results in, what implication does this bit of logic have in terms of using newer versions of the C# compiler against older runtimes? Because I really want to stress the fact that the C#, again, I made a random, just a random like rant, like last week or something about targeting different versions of .NET and the versioning misery that Microsoft caused. But what implication? I mean, I think I just gave it away though. The implication as far as how this code works in terms of compiling for older versions of .NET.
I thought it was going to be a problem with newer versions, where if Microsoft turned around and decided that they wanted to add a print name method to something, then it would cause this to blow up because
Nope.
it would then conflict.
Well, kind of, yeah. It's the overloading would take into effect, but
Still, it could potentially break.
potentially. But
I was right.
But anyway, the answer though is the fact is that you can, if you have a .NET or C# 3 compiler, you can compile to .NET 2 and use extension methods. And again, the only reason I'm pointing this out, again, it's random fact of the day. Nelson loves programming history, so you guys got to listen to me talk about it all the time. But it's just the point that I want to make, that the C# compiler does a lot of transformation behind the scenes. The C# compiler, the syntax that we use with the C# compiler, ultimately gets serialized down into a very, very basic code that's very similar to C# 1 itself. In fact, a lot of the syntactic sugar provided to us by C# 3 and 4 and now C# 5 is really about transforming your code, providing us little constructs that we can use to repeat, or to build patterns that we can repeat over and over again and save a lot of typing. Doesn't this invite to breaking earlier mentioned solid ideas or the OOP ideas? Oh, yes, certainly it does. Well, it does to an extent. Well, yeah, it does. See,
it's doing so less and less. Give it another 2 minutes, and it will be not at all.
See, the thing about it is words. Like I've already been saying this. The fact that I've been talking about Link. I've been saying, Link is amazing. It's a huge paradigm shift. It's caused a resurgence in functional programming ideas. It was probably one of the reasons why F# was even created to begin with. But we can't really talk about Link, which is frustrating. But Link is the perfect example of extension methods changing everything.
It does make it a lot easier, although aggregate's horrible. No, Moose, no. So you're saying you might break your code whenever you make an extension method?
So you might break your code whenever... No. I mean, extension methods cause problems. Can cause problems, especially with ambiguity. Basically, if any method on an actual type interferes with the corresponding extension method, the method on the type itself will take precedence over the extension method. And in that case, you'd be forced to invoke the extension method as a static method, as you see here in line 34. Okay, so let's talk about one more thing with extension methods. This is very important. I'm going to move this ble extensions into its own file. In fact, I'm going to move it into a namespace called extensions. Then I'm going to create a new file called ble extensions. I'm going to dump my little class in there. This is the number one confusing thing people have with extension methods. So I want to really drive this point home as much as possible. Could you override something like toString? No, you may not. You may not use extension methods to override existing methods on types, basically. Okay, so notice how I just moved my extension method called printName, which is encased within the ble extensions static class, into a namespace called console application1.extensions. If I jump back over to program.cs, we'll notice some interesting problems. Our extension method no longer exists. Extension methods.
How to fix?
Yep. Extension methods must be visible, meaning you must import the namespace that the extension method exists in order to use it.
Well, that makes sense. I was expecting you to say something other than that.
I have had to... People forget this.
Okay.
It might seem you've already been using extension methods for a while, and a few other developer or people here have been.
Well, yeah, but not even in terms of that. It's just the same as anything else. You can see which namespace is in its file, and it's in one.extensions. So you need that namespace. Same as any other thing where it's in a namespace. I mean, what's the confusion?
People forget. People are like, oop, derp, why is my extension method not showing up? And here's the reason why. It gets even more convoluted in cases like ASP.NET, where your usings are implicitly created for you by settings within your web.config file. And a person will write an extension method, and then they'll be like, well, why is my extension method showing up? And then they'll be all confused because there's a level of indirection that they have to go through in order to actually add the using statement, and that sort of obscures the simple fact that you must have a using statement for the namespace that contains your extension methods, period.
Cool. I had a similar problem to that. Well, in fact, I had that problem, but I didn't. It was not because of that reason. I think it was either to-array or to-dictionary, and it was just down to the fact that I didn't actually know that they were part of Link. I assumed they were like all the other casting, like doing casting to int or casting to anything else.
Yeah, and then
like two string or two character array. I didn't realize they were part of Link, and consequently, it took me ages to work out how to get them to work, because the IntelliSense didn't show it. Resharper wasn't having it.
Fun sidebar really quickly, just because this class is getting dangerously close to ending. I want to just point out a random tip for people. So let's have some fun.
Oh yeah, it was Segfault that actually rescued me on that one. So props to him.
This is for anybody who has Resharper installed. Oh, shut up. Oh, I didn't put that in my garbage folder. No. Whatever.
You can start again.
No, then I'll have to dig through my Explorer, and I don't know what'll show up if I open up Windows Explorer. Alrighty.
Ponies, I would imagine.
Okay, let's talk about... My phone ringing. Let's talk about a quick little...
You're fired.
Quick little Resharper... why can't I type anymore? Okay. Notice how addOne does not exist.
I have noticed such.
If I type in addOne, however, it still doesn't exist. However, if you add the parentheses, Resharper will indicate that there is a appropriate extension method available to you. This will only pop up if you add the parentheses. So if you click on this or hit Alt-Enter, you'll get the using statement. However, that's not how I typically do my extension methods. Watch this. You guys want to see a magic trick? You ready for this? You ready for this? This is only if you have Resharper installed. Hold down Shift, Alt, and hit Spacebar.
Cool.
And once you hit Enter, it'll bring in the using statement. Works for Link too. So for example, if I had an array, and I did r dot, notice how there is no link in here, but if I hit Shift, Alt, Spacebar, we have link. And if I use any one of these methods, the using pops up.
Sweet.
I exclusively use Shift Alt Space instead of Control Space, because Shift Alt Space, even in cases where you just use it without accessing a member of an object, it'll also search your all the referenced assemblies for what you want, and when you select one and hit enter, it'll bring in the using statement for you. So I've gotten the habit of using Shift Alt Space exclusively.
That's just one more thing to add to my collection of combinations of Control, Alt, Shift, and Space to mash.
Yeah, it took a while to get in the habit of doing it, but I'm glad I did. It saves a bunch of typing. Because the last thing, I hate doing this. I hate typing it like dictionary, int, and then I have to hit Alt Enter, and it's just a huge mess.
I think when I was, funnily enough, when I was having this struggle that was down to not knowing that toArray was on link, was when I was dealing with go back to that extension, go back to your other file a second. No, the one that you had just there. No, it's gone.
Okay.
That's just gone.
Shift Alt Space. Shift Alt Space. Can you use the extension method to subscribe to a delegate? I'm not going to code out that example, but the answer is yes. You may use an extension method. You may extend delegate types. You may also extend enumeration types, which I can talk about. So I just added an extension method to an enumeration. Super exciting. Doesn't extending enums go against the whole idea of enums? It certainly does. I didn't say you should do this, I said you could. Remember, breaking the rules sometimes will lead you in good directions. However, principles should typically always be followed fairly straightforward until you really understand the implications of following those certain principles. Because like I said, I break principles on occasion. Typically, the biggest reason I would break a principle is because of time constraints. But if I were to, I would always do my best to sort of isolate the horrible code or the code that breaks the principle in a way that could be refactored easy later, sort of mitigate the damage. But again, though, there are times to break principles, and although I wouldn't typically ever add a member to an enum, I think that's kind of silly. You can do it. It's a tool you have. Okay, well, I'm probably just going to go ahead and hit pause, go on break, wait for questions to come in, because at that point we really have a design discussion left, and then we're probably going to be done with this class. So, yeah, I'm going to go ahead and hit pause. And we're back. So, a few questions came in. I can't get using .extensions. Not sure what you mean by that. Using console application 1.extensions, this is importing a namespace that I had previously defined the existence of in another file. You'll notice that in the file, the ble extensions file is underneath the extensions folder, which in C# corresponds to a namespace per convention. So as a result, you'll notice the namespace of this file is console application 1.extensions. Because it's console application 1.extensions, it's not going to be by default imported into the console application 1 namespace, which will necessitate a using directive. When will console application 1 be released to the public?
If you go ahead, go back over to your Blay extensions CS file and change the namespace to.
Yeah, if I did like, just
get rid of backspace.
Oh, right.
There we go.
At this point now, Blay extensions is within the console application 1 namespace. So as a result, this becomes an error because this namespace no longer exists. And furthermore, I don't need to do any more work in order to use the extensions that I deleted, but could be here, inside of here. We have a design question that we can spend a few minutes discussing. Mine is basically a design question that can wait. Well, yeah, let's do the interface segregation principle and then let's talk about that. Okay, interface segregation principle. The interface segregation principle is about segregating your interfaces. I mean, pretty much everything is named rather aptly. I mean, it truly is. What we're doing here is it's the concept of the basis of the interface segregation principle actually has a few far-reaching implications.
Is it about segregating interfaces?
Yeah. The idea is to avoid objects that do too much, essentially. Basically, if you have an interface that violates SRP, you are also violating the interface segregation principle. So, for example, let's say that I had an interface called iItem. We have an iItem, has a use method, it has a drop method, it has a examine method, it has a destroy method, it has a save to disk method, it has a...
I often feel like violating my ISP.
Oh, after what Comcast...
Every time my bandwidth drops.
Yeah, after what Comcast pulled a few weeks ago, I'm... Words. Okay, so...
Oh, I meant to mention to you in relation to that actually they apologised on Nessun.
On what?
The customers in the Comcast customers had a broadcast cut out the other night on Nessun.
Nessun?
They just amused me. Yeah, telly that I watch for baseball.
Okay. This interface violates both SRP and ISP. In fact, ISP, the principle of ISP is less about a violation, more about when you realize that your interface is violating SRP, you use ISP in order to make it not violate SRP. And here's the thing. The fact is, this interface iItem, we are forced to implement every one of these methods whenever we create an item, whether or not it's appropriate for that item to have that functionality. We've already actually gone over ways that we can facilitate SRP in the context of this sort of violation, where we can do something like interface IUsable, void use, and maybe like an interface iDrop. Well, let's just say all items are droppable, but let's say we have a interface item persister with a void save to disk, and so on. So what we can do is we can break each one of these groups of related methods into their own interfaces to facilitate SRP. It's a very straightforward concept. There's a few other examples I want to go over, but at least as far as this example goes, is this example clear? Do people understand what's going on, why the original iItem is bad, and how we can fix it? Because there are a few other interesting violations that aren't as obvious. Okay, so another common thing that I'll see, especially with people's DALs, people's database access layers, we might have something like class person, class address, class product, class, I don't know, shipment, and so on. And a person may write a DAL, and they may have a DAL look like this: interface iDAL. And remember, DAL stands for Database Abstraction Layer. The DAL is responsible for persisting all of these entities that I've defined between lines 8 and 11 to the database. So a common thing that I'll see is people are like, oh, great, well, I'm going to use an interface. This is going to be so extensible and awesome, but I'm going to stuff all this functionality into one thing. I'm going to have a void save for person. And I'm going to have a void save for address, and a void save for product, and a void save for shipment. And then maybe I'll have the corresponding load methods. I'll have a person load int ID and then so load person, load address, load.
Don't think much of your parameter names.
Oh, right. Well, give me a sec.
Quite like shipment person. You just FedEx yourself on holiday.
So person might do this. This is also a violation of SRP and can be saved by ISP. And there's a bunch of problems with this. First of all, what I have just done is made it entirely impossible to implement different persistence mechanisms and swap out different implementations of persistence mechanisms for the individual entities within my system. What I mean by that is that if I make an implementation in my DAL, I'm going to be forced to write an implementation for saving people, addresses, products, and shipments.
Go on, implement
I'm not going to. Basically, what I've done here...
No, but I mean, but go as far as making the signal, making it show up. Let's see.
So I have this God object right here, this huge, monstrous class that knows about saving and loading every different type of entity. And this is not the appropriate way to handle this scenario for, like I said, a variety of reasons, because a very typical thing that you might do with the database abstraction layer is to decide that I want my people to be saved in a certain way, but I want my addresses to be saved in a different way. So doing this is impossible now because I have to implement everything and I have to swap out the entire implementation. I can't mix and match responsibilities. I can't say, save my people this way, but save my addresses this way. It's not possible with this abstraction. So what you should do, the appropriate way to handle this is to create a repository interface for each one of these entities. Now, there are a variety of mechanisms in the .NET language that makes it possible to even further reduce the amount of code you have to write with generics, but the point is that even when using those conveniences, it still provides you the ability to override the implementation of saving and loading a specific entity and nothing else, and leaving the other entities saved and loaded in a different way. So by applying ISP, we increase the maintainability of our code, because now we have very specific classes that only do one thing that can be swapped out for different implementations of the DAL interfaces. So, I mean, as far as fixing it, you would result in 4 interfaces. You know, an iPerson repository, an iAddress repository, an iProduct repository, an iShipment repository. And that would be the appropriate way to handle it. You can do a little bit better with generics, but still, that's not the point. Well, NATO, basically, let's say we have a class called person service, and our person service takes in a IDAL for the database. And we might want to have a public void, I don't know, move person to an address. And we might say var person equals database load person 10, person.address equals address database.save person, something like that. Now, because our heavyweight interface is being used, there's no way for us to change the implementation of just modifying people without also having to re-implement the way in which we modify everything else. There's no way to mix and match. We're left with a very fat interface that carries around with it so much weight that essentially destroys the purpose of an interface to begin with. An interface should be a single unit of an API. It should be a single thing. It should have a single responsibility. Now, while it's certainly possible that you might, at the end of the day, have a single DAL class that implements all of the repositories for all the different types. I mean, you could do that if you wanted to, but that's not the point. The point is that by doing it this way, you lock yourself down. It's a code smell in that it could lead you into a direction of making your code less flexible. You might be saying, oop, derp, I'm using interfaces, my code's instantly more flexible. The answer is, if you don't use interfaces right, your code's just as not flexible as if you had been using static methods. So in fixed, each interface would have a load and save method. Yes, because you really want to segregate the responsibilities of each one of these things. Also consider the final. Can anybody guess the well, probably not the final implication, but one of the major implications of what I just did with this interface. Imagine we have 5 implementations of our DAL interface. 5 implementations. Now imagine that we have a new entity. We just forced our 5 implementations to break. We've changed our interface. That is a breaking change, will cause lots of misery and lots of annoying code refactoring to do. Instead, by doing what Martin Fowler calls role-based interfaces, what we do is instead we introduce a new interface with the additional responsibilities that we want to represent, thus not causing a breaking change throughout our entire code base.
It's kind of thinking about the problem from the opposite end. If you think about it from the interface end, you write an interface that does everything that you need doing, possibly, and then you end up having to do all this extra craft. Whereas, if you think about it in terms of you write an interface to provide a complete implementation of a particular job, like saving or and then you just the thing that this reminds me of most is old-fashioned hardware synths, or for those young people, Reason, where you actually wire different bits of hardware together in a chain with wires. Hence the term wiring. But you grab these different logic gates, really, is what it reminds me of. You grab different bits of functionality and just sort of strap them all together.
Yeah,
like Lego.
You've taken what you need and only what you need. And it's great.
In fact, Lego's a very good example, because it comes in the box and you've got an I triangular piece and an I 4x4 square and an I 4x1.
Right. Basically, when you get to a sufficiently high enough level within your code base, you should be really orchestrating between different interfaces, or orchestrating the relationship between different interfaces, because an interface should be a single role, have a single responsibility, a single self-contained unit of your API, and when you don't use role-based interfaces, you're going to be bringing around a bunch of heavyweight. You're just going to. Not only is it a bit heavyweight, but it also allows you to do things you shouldn't necessarily have to do. Classes should have few dependencies. Now, that's sometimes unavoidable, especially in the cases of controller logic, where controllers need to orchestrate between so many different service layers and repositories and factories and all that stuff. But typically, classes should depend on very, very few bits of your other code base. And the fewer bits that your code depends on, the more repurposable it is, the easier it is to understand. And assuming that your interfaces are structured properly and designed properly, reading out what dependencies a class has in terms of what interfaces it accepts in this constructor should always give you an indication of what exactly it is that that class does. What do I mean by new entity? When I said entity, I know I haven't really defined that term yet. It is an actual term. But when I said entity, I was referring to an additional thing that's savable. So a person, address, product, or shipment.
One of those rare occurrences where it is the same in the real world.
Yeah. Well, it's a little bit more specific in programming.
Yeah, it'd be awkward, don't you?
I wouldn't, in the case of fixing this code, I wouldn't make it so that the DAL loads and saves objects. So somebody did suggest something like this, where you have void, something like this. I wouldn't suggest doing that. I would suggest instead creating 4 interfaces instead of 1 interface. I would say create a interface iPerson repository, and then an interface iAddress repository, and so on. I do really want to point out, though, that in production code, this particular bit of logic is, I don't find myself doing this very often. Here's why. I typically use an Hibernate or another ORM as a replacement for my DAL, which in a sense could be considered a violation of SRP when you think about it. But so I just want to point out, though, that I typically, what this would be appropriate for is not so much as interacting with databases, but interacting with something more complex than database. Because the problem of loading and saving something to a database has been solved by ORMs. That problem no longer exists. But it doesn't mean that you won't have instances in your code where things aren't saved to a database. They're saved to, I don't know, some random encoding sent to some third-party application that was written in like 1999 in VBScript and runs an Access backend. So something like iHasInventory, adding an inventory to any game object would be something you'd want to do rather than putting the inventory into the game object. Well, yeah, kind of. I would approach that particular problem a little bit differently. I would approach that problem with composition. So I wouldn't, if I have an interface called iGameObject, I will not put very much stuff into this. I will leave this as anemic as possible, because everything I put in the iGameObject interface is going to force additional weight on every implementation of the iGameObject and cause a whole lot of misery.
Segfault gave a very good example, relevant. Why would iRoomConnector have an inventory?
Right. So instead what I would do is I would make another interface called iInventory, or maybe even more generic, iContainer, that contains items. And then I would have my player, which would use interface inheritance, and it would have a container called inventory.
Are you allowed to use iPlayer?
Why wouldn't you be?
I'm just thinking copyright, you'll get sued by Apple.
I should do a iPod.
Actually, no, you'll be fine because it's an uppercase I.
Oh, right.
Sorry. It's getting late.
Would you write it as such that iPerson repository and iAddress repository implement an iRepository interface? So you can manipulate them, say, using a list of iRepository.
Yeah, I quite like that.
iRepository base classes scare me. The only instances where I would use one is if they were generic.
Actually, it is an example where I have actually done it in my code, but which is, we know all those submenus for the creation menu.
Yeah.
I actually implemented I had an I submenu that implemented iView, and enforced something. It was something or other I wanted to enforce across all. Oh, I wanted them all to have a controller, to all take in a controller into an init. So I enforced that in the something like that. There was something that I wanted to enforce across all of them. In fact, no. Actually, it was specifically so that I could do what he's said in that question there, and then I happened to add something into it that they all needed. But it was so that I could then have a generic, if you like, a specific generic for those? Or is there a better way of going about it?
Don't get me wrong, that's a perfect example of something you would do. I guess I should back up and re-answer the question. There is no situation that I can find useful for containing a list of iRepositories ever. While it's perfectly acceptable that you could have a list of iSubmenus, having a list of iRepositories makes kind of no sense. Because iRepositories are typically very specific things.
Yes. To clarify, if you'd written the question, would you write it such that I person Blair, and I address Blair implement an Blair interface?
I wouldn't do that on entities either. I would do it on something. What you said was a good example. The submenus is a good example. That's something. Those things are so. Not only are they closely related, but it's a very useful concept to think about having them contained in lists and iterated over.
Do you want to stick a shorthand version of that up as an example so that everyone else knows what we're talking about?
Well, yeah. So something like where you have, interface, I step 1, void show void hide.
Step 1 is in a shoe, step 2 is in a slipper, step 3 is in barefoot. Sorry.
The way in which I would refactor this code is by pulling up the show and hide methods into an iStep interface for 2 reasons. First of all, every step has a show and hide. There's no reason to have them in existence on every step explicitly. The second reason is it's a very useful concept to be able to contain all of my steps inside of a list, so I can loop over all of my steps, because that's a useful thing to do.
Indeedy.
So iItem is a good example, but iRepository not so much. Yes. See, iItem is great because not only do items all have similar things, all items have strings. All items have names, but you also very commonly will place a bag of items in a list. So that's a good example of when I would factor the interface up and use interface inheritance. You what?
Never mind.
Okay. But repositories, there's no reason why I would ever put that in a list.
I've never had cause to use the word repository until meeting you, so...
You have what?
It's just not, I don't know, yes, naming conventions and stuff and things.
Okay, so is everybody good on ISP? Does that sort of make sense to everyone?
ISuppository, says Soapford. No. Right. I think that's a fairly comprehensive introduction, not to completely contradict myself. And that's it, really, is it not? Except to say, what is the homework?
Yeah, well, the homework, basically what I want to see people do is...
Write a game.
What?
Write a game.
Yeah, we're getting really close up to the ending of this. We have 1 week left. The last week isn't actually... The homework is very purposefully not complex. So basically, by the end of this, we should really have a nice little RPG game that people can use. And what I want people to implement this week is the concept of an inventory.
Which is like an inventory. We'll do it again, NATO. And yes, Segfault, that's where that Dyson bloke works, at an inventory. It does sound like sort of Willy Wonka. He sold up the chocolate factory and moved to the inventory. Is the user of the game not the player?
Yeah, that's sort of weird. Whenever I think player, I always think about the object, the actual object player, and I think of the user as in the person sitting at the keyboard. Isn't this week the same as last week? No. Is it? I hope not. That'd be bad. We actually didn't have last week.
Last class. But last class was...
yeah, something different.
Well, you can bring it up. Last class was the thingamajiggy. Segfault, what was last class?
Ooh, no, we did do this last class. You know what happened?
My mind's gone completely blank.
You know what happened?
You read the wrong number off the thing.
I did.
NATO's linked the thing quite helpfully.
I read the wrong homework last week, basically. Because our weeks are off by one, and off by 1 hour.
What was last week's homework then?
What I just typed up.
I mean, what was...
It was supposed to be allow the user to interact with items from within a room, so allow them to do sort of...
Pick up and drop things.
Then it was sort of repeated in this particular homework. But really,
oh yeah, that's right. It was moving the red ball into the blue room in the vice.
Yeah.
It was that, wasn't it?
I think so. Well,
then make sure that you've done it properly.
Well, how about this? Write a game. Build a game. Do cleanup. Look at your code. Think about how you would extend your code. Add a feature to your game that...
Yeah, no, that actually would be a good homework. Add a feature to your game. It should... What should it... To be timed items. Could be a map. If you're feeling really ASCII, if you're into your ASCII art, make a mapping system. What else could you have? Secret doors, or things like that. Sort of traps, some sort of.
Or how about
some sort of trap?
Something like this: allow the user to pick up an item called a scanner.
Hey, now, no.
These are suggestions.
At least you didn't call it a PDA. I don't know Ravalli, but yeah.
Okay.
Yes, I mean, don't go nuts.
Well, no, go nuts. I mean, I
feel free to go nuts, but don't go nuts on my account.
Well, at this point, we have talked a lot about some strategies that we can architect the game, and you know what I really hope? This is what I really hope.
I'd like to see an idea that we haven't.
Yeah. You're free.
Like to just
add at least one feature to the game, and here are some suggestions. But you know what I really hope? I hope somebody picks a feature. They go to implement their game, and they realize how difficult it is to add it within their current code, and then they start to understand some of the reasons why it might be difficult in the context of some of the design discussions. That would be the most perfect outcome to this particular homework is not being able to implement something because of a poor design decision, and to be able to recognize what the poor design decision was. Even not necessarily recognizing what the poor design decision was, but maybe able to or force you to refactor your code into a better way. Because these are the sort of exercises, these are the only sort of exercises that will lead you to be a better programmer. We can talk about this.
And it doesn't matter how, it doesn't matter how many times Nelson design. See, if you do it this way, you won't have to, until you've actually sat there and then somebody turns around and goes, oh, now, what, do this, can we have this? And you go, yeah, because you should always say yes. You should always say yes first. Well, no, you should say how much, and then you should say yes. And then you should go away and find out how to do it. Because at that point you'll go, oh, I've got to rewrite this 18 times and add bits to all over my code, and then your code will break and you'll have no clue why. You'll get an index out of range exception somewhere.
Yep.
because you've changed something. It's astonishing how easily your code can get completely lost. Keep backups would be my advice.
Or use source control.
But yeah, and I saw Musaru did comment in BuzzNet, Gav is just daring someone to top his Hyperion ASCII me up. Yeah, I am, actually. Go ahead and beat that. Because the funny thing is I haven't looked at the code that does that. I have a horrible feeling that code will be just awful spaghetti code. Because I did Hyperion. Hyperion was the first.
Wasn't that what you were learning C# then, weren't you?
That's the first C# I did. The only programming tuition I've had has been what's available on 3D Buzz.
Yeah. So yeah, and people are free to go to the open office hours, and we can go over your code. We can go over strategies of making it better. Again, though, the fact is, like we said before, and I'll say it again, if you know how to loop, if you know how to write if statements, if you know how to use variables, if you know how to dynamically allocate memory, you can express any program you want to. Now, it might take a while. You'll bang your head against the wall. You'll work and rework the algorithms to it. You'll search around, read white papers, but eventually you can get it done. When it comes to design, it's all about not getting something to work, but getting something to work in a way that is extensible and maintainable. And so that's why I really like the idea of the way the homework was structured in this class, is because it provides us, especially right now, I'm actually quite happy that I messed up on the homework, because this is, I think, going to be one of the most important homeworks of this entire class. So you could gauge your own design and hopefully spend some time reworking it into a more appropriate architecture if it doesn't work. And if it does work just great, then you have affirmed good design, which is it's a win-win.
Yeah, and because one of the things that I do like the way this class has worked out is, particularly we've reached kind of by accident today, but is the fact that taking the training wheels off is the single hardest thing with programming. It seems, speaking from personal experience, because I came to 3D Buzz looking for 3ds Max tuition. I was for modelling, and then switched to programming. And the programming, much more so than the modelling, and much more so than many other things, that jump from following tutorials and even understanding every single part of a tutorial and starting with an empty file or even a partially there file and modifying it is the hardest thing to do, and it's very much harder, it seems, in programming, because all of a sudden, I don't know if it's something about the IDE and the fact that you're in this IDE with the blank, you've got to immediately start naming things and writing things. It's just, you've got to get the idea, you've got to get, the architecture is is the most nebulous thing about it, but you've got to get it straight. Otherwise, you can cause yourself all sorts of unforeseen problems. Yeah, and pop open a new project and rewrite it. I do that a lot, and it is. There is a lot of banging your head against the desk when it comes to learning programming. I mean, Nelson's probably a freak example, but I mean, how long did it take you to get comfortable? I'm not talking about your sort of 180 words a minute insanity, but just sort of comfortable not having to look things up all the time.
Well, it wasn't really a matter of looking things up. I still look things up. I have a horrid memory. I've gotten significantly better at reading documentation. That's one definite skill. But as far as design goes, I've known what a class is and inheritance was since a few months after starting to learn C++. I've known the technical definitions of them, but design never really took hold. Design never really became something that I became comfortable with or actually fluent in or understood until I started working as a developer, until I started building applications. Because then I would notice that, I could build all these awesome toy apps and make some awesome stuff, but when I'm sitting down at work and my boss asks me to add a feature and I find out that it results in a ridiculous amount of work on my part, and then it goes into production with a bunch of bugs and I can't diagnose the problems fast enough, that just made me realize that you can learn all the technical definitions in the world. You can make your code do whatever you want. And even, this is a great thing that I think I pointed out in the C++ class, where there is this guy who he doesn't want to do away with computer science degrees, but he wants to do a software development degree. Because the fact is, you can go through a computer science course and you can learn all these awesome algorithms and deep, awesome, intricate secrets of the computer and low-level stuff and even phases of compilation and pattern recognition and all this cool, awesome stuff. And you can make cool, awesome tech demos and it'll be all great. Then you get into the real world and the first project you write just turns to mush in 6 months. Because it's really about, ultimately, right now, the way the programming field is, the way computers are, the way technology has progressed, design, getting things done quickly and having things be maintainable and understandable is more important than the algorithms themselves. You can always look up an algorithm. You can always, you just buy Donald Nunn's books, read through them, or skim through them, find out all the algorithms you ever possibly wanted to know. And that's not going to make you a great programmer because it's all about the design. It's all about building something that will last. And that's why the 1 and 2 class has been focusing so much on design. And that's why I think it would be great if people try to approach this homework this week and fail and rewrite their code and it's better. Because that would be a personal learning experience I can't replicate by just talking to you guys.
And NATO says it's exactly the same for actual architecture. It's all referencing, pull stuff in and put together in a new shape. Yeah, and the ideas of design came out of architectural research, as far as I'm aware. Nelson? It's a prehistory before Gang of Four's book, but that came out of architectural principles of patterns. Because pattern books in architecture and interior design, all those wallpaper books from the sort of Georgian and Edwardian eras.
Yeah.
In the same way that, something like Antler comes along, is based on things going back through, plants and, biological theory of how plants grow, and it's all come from non-computing sources way back.
Well, I mean, that's just how humans are, though. I mean, object-oriented programming was born out of a realization that we can represent our code conceptually in a way that would make sense to business developers. And sadly, they failed in that regard. Object-oriented design is its own thing entirely, and sadly, it doesn't have as many correlations to the real world as people thought it would. But that doesn't make learning it any less valuable, because it truly is an excellent paradigm for representing software from business applications to games to mobile applications. And then functional programming comes around, and functional programming is great for for the stuff that goes at the side of the methods. Functional programming is very nice paradigm for performing computations very efficiently and in a very stable manner. And seeing those two concepts merge in C# is really nice and heartening to see. Like I said, it's really a renaissance that we're in programming at the moment since the advent of Link. Anyway, now that I've been super melodramatic for like the last 10 minutes,
I say what we do is we answer the questions that have come in,
yeah,
and then we wrap up because we've been going a good long. We're coming up on the 3-hour mark for the live class now. I don't know what time's at for the recording, but
all right.
we're kind of into conceptual conversation that could take forever.
Yeah. Do you know if you're recording when you showed us the room entry requirement code last open office hours? Can't remember. Sorry.
The what code?
The room entry requirement code.
Oh, that. Yeah, I'm sure you would have been.
Should my player only be able to drop, use, inspect an item from within their inventory state or also in a room state? As far as a game design perspective, from a game design perspective, from a player perspective, I would suggest that using and inspecting an item should be done within the inventory. Or
no,
you should be able to do that from a room state.
If you've got a freeze on a wall, see, it's all down to context. If you've got a lever that's attached to a wall, you can still use that. If you've got something in your inventory, you should be able to use it from there. You might have something that you can only use in a certain context. Obviously, you can't drop something that you aren't holding. So it depends on whether you've separated the idea of actually storing something in your inventory from it being equipped, if you like. A lot of this comes down to context, and again, that kind of emphasises what Nelson's been saying in the latter part of this lesson about composition. If everything has drop and use and inspect and on it, then you've got a lot of things. But you see, not everything's going to want all of them. So if you have droppable, usable, inspectable, for instance, just without looking at anyone's code, I'm just literally pulling this out of what you've used in the question. But if you've got IDoable, IThingable, and IStuffable, you can then compose your objects as and how. Wow, that sentence should have stopped at least a year ago. But you get the point, possibly, if there was one.
Okay, so question regarding last week's homework. Some items are not available until a task is completed. Would you add these items to a separate inventory, not attached to a room or player, or would you add them to the user or player inventory, keep them hidden until needed? I did it the second way as I thought it would be easier to save the game, but wasn't sure which way made more sense. If an item isn't available but is still in the room, in the case that I'm talking about the scanner, I would instead most likely add a concept of a invisible item or a scannable item that prevents it from being listed in the room when the user inspects the room or looks at the room.
Or like a secret door.
Yeah.
That is only available to the player once they've found the map that tells them where the secret door is, for instance.
Right. If it's always been in existence, then make it always in existence. However, if you're referring to, let's say you press a button in a room and the room then materializes 20 items, I would instantiate those as game objects, add them to the game engine, and
sounds right. But yes, sorry, you just put that's exactly what I have, a secret door. But yeah, Nelson makes a good point. It's kind of, I think what it is, it's kind of easy to get caught up in the fact that you're programming. And if you take that step back and go, okay, it's a secret door, that's going to be there whether the player's there or not, whether the player knows about it or not, have it always there. and then deal with it in a way that checks whether the player knows, as opposed to something that it magically appears when you press the button that you're not supposed to press. Instantiate that, because that's literally, in the world of the game, that's what happens. None.
Alrighty.
And that's it.
Florin, I wouldn't do it like that. The suggestion was, as far as using the DAL like this, where the save method becomes of a extension method. I wouldn't prefer it as an extension method, and the reason is that the implementation of your database access is going to be context sensitive to a variety of different external sources, and I wouldn't have it an extension method. Extension method, for example, think about it this way. The database access layer is going to have a persistent connection to the database. By making it an extension method, you are by proxy making it a static method. By making a static method, you don't have access to instance members. By not having access to instance members, the only way to grab the connection object that connects to the database is by making that connection object be static. By making your database connection object be static, you are now preventing your code from ever able to be connected to two databases simultaneously. So just by making it...
And hear the word of the Lord.
So just making it static would actually reduce the amount of features you could have in your code. I would rather see this as interfaces so that you have more flexibility.
Sorry, was I the only one who... It sounded... You were talking then, and it sounded like knee bone's connected to the thigh bone. It's connected to the...
Yeah.
Anyway.
Alrighty, so, yeah. How's everyone going? How's everyone doing? Because I think it's about time to wrap up. Winter.
Yeah.
I just made a pony joke.
Indeed you did. That joke was very much pony.
Okay, so everyone... Alrighty, well,
cool.
Let's go ahead and hit the stop button. So, to all the future people who are watching this video, goodbye. Oh, we have an O. Hold on, we have an O. Oh, office hours. Yeah, we'll talk about that in a second, after I stop the video. Okay.
Nano.
Goodbye, future people.